everybody, Markus here. Just wanted to let you know about a new podcast I'm working on. It's called Omega Tau at omegatauPodcast.net, and it's about all kinds of things, science and technology that I find interesting. First episode is on flying gliders. Episode number 2 is on weather data measurement. Number 3 is on cancer research. Number 4 is on commercial spaceflight and Spaceship One. And number 5 is about Earth race around the world in a powerboat. Some of the episodes are German, some are English. There is a feed for everything, and there is a separate feed for English episodes. So why don't you go to omegatauPodcast.net, download some episodes, let me know what you think. Thanks, and have fun listening.
Software Engineering Radio, episode 119, DSLs in Practice with Juha-Pekka Tolvanen.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for support. Hello everybody to this new episode of Software Engineering Radio. This episode is about domain-specific languages in practice. We've recorded it at the Code Generation 2008 conference, so you're probably not surprised that it's about languages and code generations. It's a discussion with Juha-Pekka Tolvanen, Juha-Pekka Tolvanen from MetaCase. They have been doing this meta language code generator stuff for years. Before we actually get started, let me just say one thing. As you probably know from past episodes of the podcast and also maybe generally from my website or something, this whole model-driven domain-specific languages thing is near and dear to my heart. So I have quite a couple of opinions myself. So this episode is more a discussion between me and JP. So I sometimes cannot hold back with my own opinion. I hope that's okay. I couldn't resist. I think it makes the discussion more interesting, but if you don't like that, if you consider me more like a normal interviewer, a journalist, then you might probably or perhaps be a little bit annoyed. Anyway, have fun with the episode and welcome JP to the episode.
Thank you. It's a great pleasure to be here.
Yeah, we've planned this for quite a while.
Yes.
So JP, why don't you introduce yourself to our listeners?
My name is Juha-Pekka. I have been working with meta modeling and especially graphical languages and code generators since 1991, and we started then a company called MetaCase, and we have been building these languages and generators, mostly tool support for that since then.
Right. So what we are going to talk about, obviously, then is how to build languages, how to build generators. It's this whole model-driven DSL topic. And just to give you readers, I should have learned this by now. So to give you listeners a heads up about the specifics, we've had episodes on model-driven development a while ago. I think it was episodes 5 and 6, a long time ago. And we've also had other stuff on internal DSLs and meta programming. So in this episode, we want to focus primarily on some of the experiences and the practical concerns that arise once you want to scale this to really larger projects. And I guess that's also where you guys have a lot of experience.
Yes.
So why don't we start by briefly recapping what it's about? What is a meta model? What is a graphical versus textual syntax? Why don't you give us a little brief heads up how you see this world?
I noticed and listened to good podcast that you had earlier, and just want to basically say what kind of domain-specific languages we are working with.
Yeah.
So we are mostly applying almost always external domain-specific languages, and they scale better because there is no escape to the host language.
Yep.
We also focus mostly on graphical domain-specific languages, but some are also matrix or table-based, and usually they have some embedded text naturally included as well. The other key issue, what we did, we didn't do in that way in the right first place in 1991, is that we have first multiple separate individual domain-specific languages, and then we figure out that usually we need to combine them. So another thing we do is we have multiple integrated external domain-specific languages, so we can share data between models based on different languages and support group working.
So another way of saying that is that you support the definition of several viewpoints with separate syntaxes for the same overall model.
Correct.
Right. Yeah.
Correct. But nothing prevents to keep those models for different users totally, but still the modeling concept can be shared.
I see. Mm-hmm. So that goes back to the repository stuff we're going to talk about in a minute. Mm-hmm.
And our aim is basically why we have been successful with this is that we always try to do a full code generation from the modeler's perspective, meaning that if someone creates a model, then he can generate a code that doesn't need to be anymore touched afterwards.
Yeah, I mean, we've talked many times, and that's one point where I kind of think that's hard to always do. I mean,
yeah, sure. But there's a number of ways to do that on trying to reach that situation.
Right, okay.
The most typical is that you have other people who already develop some domain framework code additionally, or you have existing platforms that are already capable for it. And there's a lot of rule engines and such where you can specify the rules just by graphically saying declarative manner what kind of business rules you would like to run, how you would like to guide your telephone calls to handle like service creation, and in those areas it works fine.
But let me give an example, the typical one, right? So if you have a state machine, it's of course easy to draw diagrams with rectangles and of course with rounded corners and transition arrows. But if you have a guard condition, which can be any arbitrary expression in whatever expression language, then I think there are only two choices. One choice is you put the expression as a string in the model, which is often not that great because you have no code completion, no syntax highlighting, or you somehow write that in some manual code snippet that you then integrate with the generated overall state machine. What's your take on that?
We basically see even more approaches. One is of course this adding a string to existing model. That's the last resort.
Yeah, always works.
You can do. The other approach is that we know about the type of guard conditions or whatever they are. Yeah. So we can then a little bit classify or type them.
I see.
And then they become again part of the modeling language, which is the other extreme.
Yeah.
Then there's these middle solutions that you have already implemented solutions or libraries for these typical guard conditions or whatever they would be.
Yeah.
And then you integrate from your models to those existing components.
Right. Okay. So what you would do is you would have a library with manually written code with constraints. You give them names.
Yes.
And you just mention the name in the model.
That would be one
for
way.
Example.
Yes.
Yeah. But I mean now we are actually almost philosophical, right? Because what I would do is I would generate some kind of skeleton with a method blah.
Yes.
If the guard condition is called blah,
and
then I fill in the code. What you say is we first write the blah method, put it in a library, and then mention it.
If you have existing a framework or platform, a component library, then that's usually you would like to do. You realize that there's something that multiple people would like to use,
but even
so you put it there.
Even if it's only one person who needs that.
Yeah, then it's always possible still to generate the protected blocks. So you make a code generator.
You do that?
Well, our tool allows to do that.
Yeah.
So you make a code generator where the person who makes a generator says that guard conditions are something that you would like to write later on to the generated code. Yeah. So the person says that this is the block that you can change later on.
Okay, so we're actually not that far apart.
No, but we don't recommend people to do that, mostly because in a large scale use. So if we have external DSLs, we want to hide the complexity. Yes. We want to make development easier. Yep. And we have 100 guys who are making designs.
Sure.
Someone will not write inside the protected block.
No, I agree. And you should avoid this stuff and you should put as much as possible in the model and you should try to reach 100% code generation, but there are situations when you can't, and then you need a plan B, and I think we just outlined how that would look.
Yes, and there are multiple options, and a little bit depends your situation, what your plan B actually looks like.
Yeah, of course, yes. But I guess I think I interrupted you when you were talking about. I guess you were getting at this interpretation versus code generation of the tool itself.
Yes, I was actually. These were two other bullets that I wrote here to me to prepare.
Sorry,
is that. What we do is we treat the meta model, the language definition, DSL definition, as a data. Mm-hmm. And then we don't generate tool support. We already have an existing tool that actually reads this meta model.
Yeah.
And then builds these specific editors based on the existing meta model data. And this is important for two things. We didn't do that in this way in the first place.
Mm-hmm.
And we learned that in industry use, people who create these meta models, they want to be sure that the language creation and language modification tasks are safe. Because if they have, let's say, 100 developers who are creating models, and then they change the meta model, they may be a little bit worried about what will happen to the existing models.
It's the language evolution problem.
Language evolution. And then we can guarantee that, look, you can change the meta model whatever you like. The tool will know what kind of changes you can do, and you can't broke others' models.
Yep.
So they still load. You can see the models, and in many cases they are just update automatically to the existing models.
Yeah. And just to contrast that with, for example, EMF or GMF, the problem, depending on what kind of changes you do, is that if you build your meta model in a given way and then generate, for example, Java code from it, or an editor that is implemented in Java, and then you change the meta model, it might happen that your editor / the EMF library, whatever, isn't able to load the model anymore.
Correct.
Because the model's storage structure has been baked into the generated source code, and that's clearly a problem.
Correct. And that's obviously for industrial use. If you have a lot of models existing, we can't really go and say back to the modelers that please start again. Yeah. Because the meta model changed. That's usually acceptable.
You don't have to start again, but you have to in case of EMF, you might have to patch the underlying XMI, which is of course also ugly.
Yeah.
Okay.
But basically, we try to streamline this process. That's our
absolutely
idea.
Yeah. The other thing is. So did you finish with
I finished, yes.
Okay, so let's go back briefly to those different viewpoints, because that's something I found to be very, very important in practice, that people really specifically think about the fact that a real system is built from several different viewpoints, and you have typically different DSLs or different languages. One of them might be your manually written code that actually assembles the overall system. So can you talk a little bit about how you do this technology-wise, repository and the different viewpoints, and how it all works on one thing and still represents differently to different users or viewpoints?
We basically differentiate two things. The conceptual structure, we call it abstract syntax, and also for models, and then concrete syntax. They are totally different things. And it always should start from the abstract syntax.
Yeah.
And we basically specify a meta model, but in our meta modeling language, we have a specific concepts like a language. So we can identify what you call viewpoints. We can identify what kind of viewpoints you would like to have. For instance, you would like to have a display view. Another one would be a navigation view, a persistency view, or real-time view, whatever those views would be. But then we can identify different kind of modelers or model usage scenarios, that we need to have this kind of language for describing static structures, another one for describing behavior structures. Yet the models that are created with these two languages still share the same data. So if someone changes the data in a static view and it's applied also in the behavioral view, it automatically updates in that behavior view, just to support refactoring and model editing work.
Yeah. So in contrast, I'm always contrasting with some other tooling just to make the point. Yes. If you did that, for example, typically, it depends on how you do it with the EMF, but classically you might have literally different models, and then if you generate code, you load all of them, somehow join them, make sure you establish connections between things that actually are the same thing or that reference each other, and then you write a code generator that kind of takes all of that in and builds the overall system from these different things.
And that seems to be one interest for this model-to-model transformations, that you can combine things and you can work with them to later produce the code. Whereas our idea is to do the integration not so much on the code generation phase, but you can do it also at the modeling time.
Yeah, that's actually another point where we tend to disagree a little bit, which is the importance of model-to-model transformations. So you don't have them in the tool, right?
You can do model-to-model transformations. We even do model-to-meta-model transformations, but you can do such things through intermediate formats of such. usually we don't have found that customers really need.
So in other words, what you're doing is you generate with a code generator the textual XML probably representation of the model you are trying to transform to.
Yes, if you want to do that model, there's also API. Yeah. So if you want to use Excel to do that, okay, you can use Excel and macros and do the same thing.
Okay.
At the repository level. So you can remove data from the repository and create new models.
Yeah. Okay.
If you think that you need to have such a kind of thing, we just feel that it's better if the things are already integrated at the modeling time, because then refactoring and model working is easier. Yeah. Because we can see where the changes happen. So in our situation, if you see that something is changing in the data model, you can see maybe already that this is shared by somewhere else. And you can ask where it is. Yeah. And then you can see another diagram where the data has further details.
Yeah. I as I said, I tend to disagree. I don't disagree with what you said, but I have a lot of scenarios where model transformations are really useful. But I guess that's a topic for a different episode. I'm not sure I should put too much of my viewpoint into this thing.
But if you look at viewpoints of a consultant and a viewpoint of a tool developer, already their perspectives are different. So consultants, of course, want to reuse existing generators if they have already done something.
For example.
Whereas from our point of view, tool vendor point of view, customer have already done their own code generator. They don't want to share that with their competitor.
Yeah.
So there is less need to work with.
Since we're discussing it already, I mean, one of the areas where I think it's kind of really useful is if you think in terms of product lines, if you consider a state machine model, you always use it as an example because everybody knows it. And there is a variant of your state machine you want to be able to sell for an extra price. And that variant has what I call the emergency stop feature. So you have 50 states, and from each of them you want a new transition with the event stop that goes to a fail-safe state. Now, how do you get those 50 additional transitions into your otherwise manually drawn state machine model?
So you want that all those state machines have connection to emergency?
Yes, all states in the state machine. But
then I wouldn't model that at all.
Right.
Because everybody has that.
You would have to draw 50 lines, which is stupid.
Yes. Yeah.
But now here's the thing: the generated code, if you have an execution thingy, that it has to have those things. Now you can put this into your code generator.
Sure, but it could be a property of that whole state machine to say, in this state machine, all these states have the emergency.
Yeah, but it should be optional. But it should be optional.
Yeah,
that's the point.
That's a Boolean value in that whole state machine diagram. Will these states has emergency property.
Okay.
Or each individual state could have this property, and by default that property could be yes, I have an emergency state.
Absolutely. But now you set this Boolean flag to true. Your Boolean, every state needs to have the emergency. You set this to true in your model. So now, but you still need to generate the code that actually, imagine the state machine generated as a big switch case thing.
For instance,
now all those 50 state cases need to have this additional branch to the. So how do you get it in there? What you would do is basically you would say in your code generator, if this Boolean flag is set to true, then generate something else. And I think that's a problem. And the reason why I think that is your code generator typically says something like, for each state in my model, generate an integer constant. Yes. For each state in my model, also generate a case block in my switch statement, and so on. My point is you have this algorithmic part of the generator.
In the generator, yes.
That iterates over the model. Now, if you want to do your Boolean flag, then you always have the algorithmic part, and after that you say, and also if this thing is true, then you have this additional integer constant, the additional case block, and so on. And that complicates your generator. And if you do model-to-model transformation, just one sentence more, what you will do is, if this Boolean flag is set to true, you take your model as it is, you with a transformation add those 50 additional transitions, and then you just run the generator without the generator caring about the fact that there are special emergency things, and without these ifs in the generator and stuff. And that's really a nice modularization.
Well, you get now more sentences, but
these were all commas.
A solution for that, from our angle, would be that you realize that there are these specific emergency states, transitions, other kind of state transitions. Somewhere you have a generator who knows how to handle state transitions.
Yes.
So it doesn't need to be in this state, that information. You can abstract that into a common subroutine. So whenever you are generating code, it looks all the type of things for this state transition. And then only in that place, you also looked at emergency.
Sure, but it's scattered. You have in a typical, you have several places where you would have to do it. But anyway,
yes.
Okay, so
it could be, but then you could have multiple places in your code generator where you can
call out into other routines.
The existing routine. So the idea comes how you structure your code generator. And you can structure it many ways, per file, per section of file. Usually we see most people do it. They start to structure the generator based on each domain concept. So when they have a different language concept, they have one generator for each concept. And later they may look at, well, actually this has multiple commonalities with other concepts. And then they refactor the generator. But again, it's a work done by a couple of persons.
Right.
All the rest modelers don't do that. So if it's hard to do this emergency code generator, okay, it's hard only for one or two guys.
That's true. That's always true.
And
for
that's the whole value here. Making compilers also.
Yeah, but I mean
hard. So
and I promise we're getting to the end of this discussion now soon. But I think my experience is once your code generator grows. And once you do a lot of product line stuff where you have many of these optional features that change your code generator, the complexity of your code generator becomes an issue. Not an unsolvable issue, but an issue.
One thing to solve is that trying to raise the level of abstraction already with the modeling language. So you can put more rules to the modeling language and so that the code generator becomes smaller. The same thing if people have problems with generating code from pure class diagrams.
Yeah, sure.
Because then the person who makes a generator, it can be that half of the code generator is just checking if the input that I get from this UML diagram has the guy who created it, has it filled the properties correctly and that kind of thing. Otherwise, we are generating bad things. So if we can put to the meta model the rules to the language, the code generator can cut into half of the size.
And I'm not saying you cannot solve some of these things without model transformations. Of course you can. You do it and it works. However, I'm just saying having model transformations as an additional entry in your toolkit is useful.
Sure.
Because in that case, the only thing you'd have to do is you write like 7 lines of model transformation that adds those additional emergency stop things, and you don't even touch your code generator, and you don't even touch your model, and you don't even touch your meta model. So it's extremely nicely localized, and that's my whole point.
You may apply those if they make sense.
Yes.
We have found out in many cases you don't need those as well. It makes the process much easier also for understand and do. And of course, many people do even the worst thing that you don't do, but many people do the thing that they modify the models during this translation process.
Yeah,
the classical OMG MDA thing, which will never work.
Yeah. So just to clarify, what you were talking about is you have a PIM, right?
PIM or scene
whatever.
Model,
and you transform it into, let's say, a PSM, and then you go into the PSM, change things, add things, additional stuff, and then you continue generating.
And that won't never work because it's impossible to version and handle. And people don't know how to deal with changes in case of they need to regenerate the PSM model.
Yeah, it's the protected region problem on models.
On models, correct.
Yeah. So, okay. End of sidetrack. What we want to do in the rest of this episode is we want to look at a couple of experience from your practical work with real customers. You've been around for a while, so you have a couple of them. So we want to do 2 things. We want to look at a couple of example languages and then discuss why that has been successful, couple of metrics, couple of best practices.
The challenge with these examples is that unfortunately the best examples are something that are done by our customers. So it's totally the IPR.
Sure.
So they would come and kill us if we show their languages, because you can see from their meta model everything what they plan to do.
Yeah, right. Yeah, so that's why we don't see. Luckily, we are in an audio medium where we cannot show anything anyway. So the first case we're looking at here is insurance stuff, and I find that interesting because I have worked in the insurance domain also. And what is interesting is that the cases I have seen was that we use textual languages. So I'm surprised, or whatever, that it kind of is useful to use graphical languages in the insurance domain. So what did you actually describe with those graphical languages?
Different kind of financial products and insurance products in this particular case. And this is a broker for insurance products, providing a web portal. People can compare insurance products of different type. So let's say that if I have a car and my car is at night in garage, do I get a better discount for the thief?
Yeah, right.
Or whatever. But you're right, the same kind of rules are also done textually. Also, Capgemini has been working with the pension rules, which is again Excel. So sheet-based.
Well, that was old, and now they've done intentional stuff, and of course that's what I was referring to.
Yes. Okay, that part. Yes.
Yeah.
And they already had a domain model, the thing they call domain model, which means this is what all insurances are about.
Yeah.
And for some reason they had defined it by using a MOF.
Yeah.
And they asked, can you then? We would like now that people, insurance experts, can specify insurance products. So that they could then generate code out of the models, in this case Java code, into J2E websites.
And that code is used to actually execute the calculations and give people a heads up on how much they're going to get and how much they have to pay, blah, blah.
Correct.
I think this is interesting because unlike many people think that this model-driven stuff is only relevant for like technical people, but this is really used by domain experts.
And to be totally honest here, we were also surprised. That once we heard that the language that they ask us to co-develop with them is something that they give for non-technical people. They give it to insurance experts to specify.
So that's not Joe Insurance sales guy. It's rather the experts that actually define the contract.
Correct.
Yeah. So these are these mathematicians, or these are structured thinking people. That's true, but not conceptual thinking people necessarily.
Yes.
And who actually built the language? Did they do that?
Actually, we, in this particular case, we did that for them.
Okay.
So they had the domain model, they have the MOF model, and they said that, can you put this into a language?
Yeah.
And we asked them, like here, what the language should look like.
Yeah.
So we are looking here a slide with the concrete syntax of different traffic signs, and so we asked them to specify how they would like to look at that, because then it becomes their language.
Yeah, sure, yes.
And then we implemented these rules together with this Java generator, and we did that in 11 days, if I remember correctly. And it was quickly done, partly because they already had a good domain model.
Right, so the knowledge was already there and structured. It was just about building the UI, the nice editor.
Building only the language, because building the editors and building the generators and building the concrete syntax. Of course, when they had the meta model specified by MOF class diagram, it didn't have all the rules.
Sure, yes.
And only later, when you try it out with them, they realized, no, you can't make such a thing. Our domain model don't have this rule, because the domain model is just a piece of paper, not something they run. Now they can run the domain model, and then they realize that now they need to specify it correctly because it's executing now.
So what's interesting here is that this is a case that shows that one way of getting to a good language is that you just take the existing concepts and stuff that domain experts already have and formalize them into a tool.
Correct.
Do you know of, and that's of course somehow ideal because you already know what to do.
Yes.
Do you have thoughts about what other approaches there are to come up with a good domain language or DSL?
We wrote a book.
You can plug it. We'll put it in the show notes.
We wrote a book on this, and actually a paper for software product lines a couple of years ago to look how people are building languages. And one of them was that they already have established domain vocabulary, domain concepts like here, and they would like to apply it.
Yeah.
The other kind of thing is that the product has a clear physical structure, like let's say a home automation network.
Stopwatch.
Stopwatch is another example to my mind. That you have a clear structure, let's say a battleship communication system, or forklift in a lorry. You can see that, okay, it has so many cylinders and so forth. That's your language.
Right.
The other sort of domain-specific languages are those which are based on look or feel or hear, of the system.
Yeah.
So like user interface,
right?
Dedicated languages like in a mobile phone or diving instrument or this kind of advanced watch with a number of features like the stopwatch or lap time or timer or alarm or
I was joking because that's your standard demo and I've seen it 5 million times.
Yes. Well, we use the digital wristwatch as an example because it's everybody knows the time and everybody usually owns, except Markus, owns a watch, but people know how to do, and you can build surprisingly many applications for that. Like we were discussing a watch for people when they're playing a chess. They can see that how much each two players press the chess. Right. So you can build enormous number of different product lines, like the watch industry is doing.
Right. Yeah, and another case that Krzysztof Czarnecki has been talking about in the episode where we interviewed him, obviously, was that you might have a framework and you want to provide a nice DSL to configure the framework.
Yes.
And in that case, you would derive the language from the framework.
Correct.
In some sense, it's the same thing as with your forklift, but it's now software that you derive it from and not a physical device.
We would call that, if I understood correctly, is that you look what is your existing APIs, what is your existing code, and then you abstract from there languages. But there's also place to warn in this kind of situation is that you may end up in this way into a language which has a low abstraction level, but added with the rules to use that lower abstraction level.
And Krzysztof calls this stuff a framework-specific modeling language, in which case the low abstraction level is not a problem because that's the whole point.
Sure. Yeah. But of course, in the worst place, it is that for each API, you have one language concept, which is a horrible solution. But maybe you can analyze that further to see what is the underlying programming model, how those frameworks are used, and then you can abstract further.
And to come back to the model-to-model transformation thing, you can use that framework-specific or technology-specific modeling language at the bottom, and then you build your higher levels of abstraction that are more domain-specific, and use a model-to-model transformation to go down to that existing one. And that makes a lot of sense if there is a lot of very intricate coding patterns in the generator, like in many embedded applications. You have all kinds of pointer crap, and so you want to abstract that layer so that it's clean, and then you can generate or transform to that layer. It's another example where M2M is useful.
Yes, but again, there's alternative ways to solve that. Just to work with that example you mentioned, you may have a higher level language that someone specifies. Then you change the meta model for that high level language, which is more expressive power. And then you give it for other people. Let's say you have people who do high level user interface specification, and they use a language and specify the behavior of the system in a general view. Then you give that model to the technical people who analyze it further details and change the meta model behind, which is a complement with this earlier meta model. But then you don't do any more model-to-model transformation. You use the same model, you just change the meta model, and then people can continue with working with the same model for further details. That's another way which people see how to work with the models at different type of usage with different levels of knowledge.
You mentioned that those insurance guys had a MOF-based meta model available.
Unfortunately, yes.
Yes, and I noticed your opinion there that you're not that much of a fan of MOF. So don't you use MOF as the M3 level as the meta model?
No, we don't. But the problem with them with using a MOF was that the MOF version was changing. So even though this was done in 2 months, they quickly shocked out. Now we need to start again because something has changed, which is nothing to do with this whole thing, but just to follow this.
Right.
The other thing that they had the problem with this was that then the meta model became surprisingly complex because they wanted to include all the stuff from the MOF to the underlying language, and we want to say, please, you don't need this.
But that's a design mistake. That's not MOF's fault.
Yes. No. Yeah. But it guides you to do. It guides you to specify for each language concept, is this abstract, is this rude, and all that stuff. Well, we don't use MOF, maybe partly because we are using a repository-based approach to build these tools. So we defined the data structure, and we did our work before MOF, and we did our work based on other tools that already worked, like QuickSpec or SPLC, PSLA, which work at 70s and 80s as a meta systems. So we try to build on something what works rather than build something on
paper.
Standardized.
So what's the difference?
In a paper.
What's except for standards versus working? What's the difference between them?
In my opinion, the MOF is pretty complex, and all the tool vendors who have tried to implement or part of that have ended up on implementing a little bit something else, and they call it then maybe XMOF or whatever, or MOF-like or whatever.
Yeah.
But we have, for instance, a specific concept of a language in our meta-modeling language. So we have only 6 concepts in our meta model, and one of these concepts is a language. So we can guide people now to look how languages can be combined, how we can hierarchically structure languages to have a sub-models based on different language, which MOF doesn't guide you at all.
Yeah, it's possible, but it doesn't guide you. That's your point. Yes.
With this GeoPR meta model that we have using, we also can guide people to do the meta models. Like, look, you have specified relationships, but they are not binded correctly.
Yeah.
We can look ANA relationships, so we can have a connection from one object to multiple objects at the same time. So if the connection changes, we only change it one place rather than drawing the line for 500 times for each, 50 times for each emergency state, and give specific properties for these 50 lines. Yeah. But in our case, you would actually draw one line for those 50 if you would do that way, and all the properties of that line would be only entered once.
That's the point. You still have 50 lines, but they would be collected in one point at which, and that you would have 50
line ends.
Right. Right. Okay. So in other words, the association.
If you would do that thing.
Yeah. The association would be, to pictorially speaking, would be a bubble that contains all the properties, and then you connect this to n.
Yes, in our case, it's not necessarily a bubble. It's just how you want it to be illustrated. It can be just a line as well.
Of course.
Yes.
Yeah. Okay. So the next example is this mobile point of sale, which I really like because so it's basically about building a PDA-based sales application.
Correct.
And the language you use for defining how the application works uses the same syntax more or less as the final application.
Correct. Correct.
The reason why this works is because your editor framework allows you to have really nice interactive pictures. So you want to talk about that a little bit?
Yes, of course. I would like to speak about our product.
You don't have to. I mean, you can talk about other products if you want.
Well, in this particular case, we basically, when we start to discuss how to get domain concepts of different time, you mentioned this framework-based approach. I also mentioned earlier this look and feel-based approach. This is an example of that you derive your language concepts from your view from the end product.
Right.
So we have here a notation that looks like the running system in a mobile phone.
Like widgets, combo boxes.
Like widgets, exactly. And also the navigation flows. But there are also other nice things like people, rather than writing the code for this concept of login, so there's a login application in the beginning that you need to do. Yeah. Rather than specifying the code for login, in our modeling language, there's now only one object called login.
Yeah, you've abstracted
and it
the
doesn't
whole
have any
UI.
It doesn't have any properties.
Yeah.
You just say that I would like to log in, and you add this orange L rounded symbol to the drawing area, and then you connect to the next step, like here to the main menu structure. Yeah. That means then that you would like to have a login in your application and then go to the main menu.
Yeah. And of course, to make sure people don't think we're doing advertising here, the point we're trying to make, I think, is that
abstraction. Yes,
abstraction. That's the logging thing. That's one thing. But the other thing is that in order to get acceptance for your DSL with your users, you should try to make sure the language uses visual syntax that is as close as possible to what they have been working with before.
Correct.
That's here the UI thing. And in case of the insurance stuff with intentional, just to elaborate on that, and Capgemini, this prototype they've publicly talked about, the idea was to take their existing language, which they had before in Word documents and stuff, and just formalize the language and build a tool around it. And again, so people, users, were working with stuff they had been working with before, but now with a much better tool and much better constraint checks and much better automation at the back end.
Correct. Sometimes a very good source for the concrete syntax is the PowerPoints people do. when people, many people do PowerPoints, but when they do use PowerPoints for design, then they are totally free to choose whatever design style they feel suitable for that task.
Mm-hmm.
And if then they realize the number of people start to use PowerPoint similarly,
Mm-hmm.
then obviously there's some reason behind the vocabulary and the way they specify things with PowerPoint. So in a good situation, you can take the notation from the PowerPoint and put the structure there behind your language.
Yes.
And then you can give it back for them, and then they can say you can continue specifying your PowerPoints, but now you can also produce running products.
I was once involved in a project in mobile phone industry where we build a prototype for doing something similar with, of course, other tooling, but it doesn't matter. So, and I went to this customer and they said, we do have quite a good understanding of our system. And he comes with this Visio file, which had like 200 Visio diagrams. They had even created their own shapes, their own palette, and they were specifying the requirements, or they're specifying their applications by visually composing their custom shapes. And these shapes, of course, would be box, drop down, button. And then they took that literally, once they draw the picture, printed, and people implemented it manually. And I thought, guys, you can't do this. Why don't you generate? It's exactly the same case, right?
Yes.
Okay, the next 2 or 3 examples are basically process descriptions, right? The first one is about a voice voice application to which you call
voice menu. Yes,
voice menu.
There's 2 different type of diagrams.
Mm-hmm.
There's the high-level view for the system, and then each individual loudspeaker-looking symbols are described in this other diagram in more detail.
Like voice interactions.
Yeah. And then the code generator basically reads the models from the top diagram and goes into these sub-diagrams to produce code out. And this is a case of 8-bit microcontroller.
Mm-hmm.
So very important for them was to save the memory. So it also looks if the same strings are multiple times repeated in the in the voice menus, and then you use the same memory addresses for that voice strings.
Yeah. But the code that's generated uses a specific language. There's the speak things. There are primitives
of their own. Of
their own.
Yes.
So you could argue that is one of those framework-specific modeling languages. The language already existed, and you have built a nicer, more user-friendly tooling on top of it.
Yeah, you could say so. Yes.
The next example is a Telecom service configuration language. And as people probably know, services in Telecom with all this quality of service stuff are quite complex. So what did you do in this case? What's the reason for building that language?
Actually, we don't know.
Okay,
because the customer made it all by themselves.
Okay.
They asked us a couple of emails, and then what they did.
Okay.
What they want to do is that obviously writing these configuration scripts manually is error-prone.
Because of implied constraints.
Because implied constraints, and because they are using it in a running system.
Yeah.
So they want to be sure that they are configured correctly, and they realize that they are repeating same kind of patterns.
Yeah.
And that's they abstracted to the modeling language.
Yes.
And then having rules in that modeling language, they can be sure then that the specifications they do for service configuration are correct.
Yeah.
At least to some extent correct.
Yeah. So the point was abstraction and also, in some sense, static constraint checking.
Correct.
Instead of doing it, putting the stuff in the ini file and watch the system crash because you did something wrong, you put the rule in the language. And you can't do it wrong.
Yes.
That's also a very good use case.
But many domain-specific languages has always this error prevention aspect.
Yeah.
That the earlier we can put the rule to the language, the earlier we can prevent illegal designs or designs that lead to a poor performance.
Yeah.
And then they're also cheapest to correct because we don't even allow them to happen.
And of course also, because the error messages are part of the DSL, they use domain-specific terminology as opposed to out-of-memory error.
Yes.
Right? If you crash in the low-level system. So it also makes the potential errors more convenient for users. The next one is something I've seen you, I think, demo, or I've seen your customer demo at the Ulrich Eisenegger conference at some point, I think.
Correct.
It's about infotainment systems. That's your, radio, video, mobile phone in the car.
Yes, and they are getting today extremely complex.
Yes.
So the luxury cars can have up to 1,000 menus in a car.
Yeah.
So obviously someone must design them carefully what they mean.
Yeah.
And in this particular case, what is interesting is that there's actually 3 different viewpoints, like you said.
Yeah.
Sub-languages. So there's people who are, let's say, the artists who define the layout part. What are the colors, fonts, icons, themes, so what it looks like. Then there are other people who have another viewpoint, another meta-model language, who specify the individual displays for the system, so how they use the screen estate correctly and intuitively. And that information they use and specify is again applied by another viewpoint where they are describing the interaction with the system. And if someone now changes the content part on the individual static display structures, those changes can be reflected automatically to those who specify the behavior. So if they add something to the display, then the people who are specifying the behavior can see that now we need to add new functionality because there's a new visualization available and so forth. And they do this for generating the code. Usually in automotive, they do some code generation, let's say in a browser in Java, that they can quickly prototype and try it out whether it makes sense.
Simulator.
And automotive industry works today so that there's then subcontractors, first level, second level, who then do the final implementation. But basically nothing prevents to change the code generator from Java to the native, let's say C implementation.
It's a little bit about trust.
Yes, and partly maybe also the rules how the industry works. So for example, if you are generating part of the code first to Java, it works wonderfully, and then you would like to say the same system now in C, please. But if you generate the code from the models that let's say the brand created, the automotive manufacturer created, and then you ask subcontractors to do the implementation by using the generated code, who actually takes responsibility of that generated C code, which goes to the target.
I really think this idea of multiple viewpoints or multiple sub-languages is kind of extremely useful. I mean, not that this is something I just noticed, but it's important to communicate.
Yes.
Okay, so I guess this was or these were some of the interesting examples. I guess those case studies that are publicly available, we'll put links to them in the show notes. Is there anything else you want to say? So to wrap up this thing slowly but certainly,
I would like to basically mention that companies who have tried these kind of domain-specific languages say usually that there's a productivity increase is a fundamental. Some companies say that, let's say, Panasonic wrote a paper to the Uppsala workshop that they claim to be now making same application now 500% faster.
That would be 5 times.
5 times faster. And Nokia claims that they are maybe making now product line a mobile phone. They are making it 10 times faster compared to earlier manual practice. So it's a huge improvement. And
what's your experience in the initial investment? Because I mean, you have to build languages, generators, and stuff.
Yes.
So how much? I mean, how does this stack up? How is there any metrics you can give?
We have tried to measure, of course, all this information what we have, but we have also noticed that the circumstances or the background for the company cases are always a little bit different. So direct comparison is difficult. But we have found out that code generator usually takes more time than making the meta model, for sure. Concrete syntax sometimes take more time than making the abstract.
Yeah, because you can polish it
until the end that you have a really nice looking Word documents generated and so forth. You can do a lot of effort there. Most of the time companies seems to have with the underlying frameworks. So if they have a product line which is actually a copy of the earlier product, then it's more difficult to apply code generators if the basis and the foundation is not there. But if companies have already realized that we have a reusable components, we have a reusable pieces of or we have a component factories, a team who do common platform.
A platform team is always suspicious.
Yes. Then there's a good chance. But because of these quite a huge productivity increase, or even academically proven cases, my summary would be actually for people to try out of different tools and try to outbuild domain-specific languages and take the low-hanging fruits first. So pick those cases where you can show immediate benefits even though you may feel that they are too small and you would see more interesting thing to tackle. Right. You can do that later.
Yes. Once you convince management.
When you convince your colleagues who don't believe that you can generate code.
Yes.
Or you can convince your managers that they see, wow, this gave a good return of investment. Yeah. Let's use this more.
Yeah.
So easy case first, and then if there are help from people or discussion groups, or even tool vendors or consultants, feel free to use those. That they provide such a service.
Especially consultants.
yes, I understand your point.
Okay, so JP, thank you very much for being on the show. I think it was an interesting discussion.
Okay, thank you. It was a pleasure to be here.
Thanks for downloading and listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under a Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the PodSafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.